Hey everyone, I'm hoping, fingers crossed, that you can currently see my face and that the YouTube page that you had open has just gone like, I don't know, it looks like me or something. If that isn't the case, that is a slight bit worrying. Is it working? If you could message me and say hey or something, that would be really cool, just to check. I think I might be here, but I also think I might not be here, which is also worrying. Let's have a look. I'm going to try and look on my end and see if I can sort it out. Yes, you can see me. Yay, it's working. Cool. Right, so my plan today then is to hopefully go through some revision questions that you guys should sort of know something about for a webinar. And I'm going to sort of base this to be guessing people who are doing year 12 or year 13 and sort of try and get a mix of everyone involved so that hopefully we can all leave here feeling like we have a good idea of sort of what's going on. Okay, so I am going to share my screen with you. Again, please let me know if you can't actually see anything and I'll try and deal with that problem. Right, so if I share this and put that on my full screen. Take your time, laptop. There we go. So how long is this? I can see someone asking if we are here. This is going to be roughly about an hour. I am going to probably spend about, well, the majority of the time I'm going to spend going through stuff, and then I'm going to tell you a little bit more about SnapRevise at the very end, just because I imagine some of you probably don't know very much, and I'd like to do as much of that as I possibly can. I'm trying to get your comment popping up. There you go. Yeah, so it's about an hour. Right, so yeah, essentially today then we are going to be doing a whole load of exam questions. So just to introduce myself, for those of you who don't know who I am, my name is Ollie. I am the head of biology here at SnapRevise, where I've been working for a little while. I've got a bachelor's degree from the University of Southampton in biology, so I'm pretty good at this stuff. And as well as that, I've been teaching A-level biology for the last like 4 years or so, on and off. On and off, I say on and off, I mean pretty much just on. I've been teaching for 4 years doing A-level biology, so hopefully I am one of the best people to be telling you how to do stuff on a Sunday. How are the rest of you though? You guys all good? Ole Gunnar Solskjaer. He weirdly was my favourite footballer when I was a kid because I spelt my name like that for a bit because apparently I decided that was cool. You applied to Southampton. I am pleased. If I could give one tip for biology, what would my one tip be? I reckon you need to spend some time sort of, I don't know, working out things you don't know and then going back from there just because there's so much to learn. So I say that's probably quite a good tip. Right, anyway, guys, I will start talking. I'll start going over stuff. It's mostly the year 12 stuff because I wanted to try and make sure that everyone had something. There are a few year 13 questions in here as well. Congrats, person who got an interview from Oxford. So also, just so we all are aware of what the point of this is, I'm kind of doing this so that we can have a look at some questions, because I think probably the biggest problem that most students find is that they just don't know how to answer questions properly. So we're going to do some question analysis. We're going to look at some mark scheme language, or I'll go through that with you. We're going to look at some exam technique and look at a range of questions too. Okay, so, oh, one other thing before I forget, because I always forget this. If you follow us on Instagram at SnapRevise and basically tag us in something, one person watching this right now will end up getting our best account that we've got. So our top account, we have one sort of prize sort of thing for one person. So if you want to be in with a chance of that, feel free to tag us and follow us, and we'll give one of you basically a free account. There is also a coupon code at the very, very end, which you guys can have a go at using too, which will get you, I think it's like 40% off. So you can use that to sign up if you would like to, if you are happy with what we're doing. So this stuff, good question. Those of you asking Valencia and Ivana, is this OCR, EdXLA, whatever? Sarah Wong as well. Ooh, a coupon. Yeah, so the way that SnapRevise works is people like me who are the tutors, we make all of our lessons so that they cover absolutely every spec. So this is probably the hardest part of my job, just working out what bit is AQA, what bit is EdXL, what bit is OCR, what bit is EdXLB, and basically putting it together in a way that allows everyone to get as much as they can. Yeah, this video can be replayed after as well. So let's have a go then. So the first thing that I'm going to talk about, the first thing that people sort of don't spend too much time actually looking at is the enzyme stuff. So first question, pepsin is an enzyme that digests protein foods in the mammalian stomach. Protein molecules are made from chains of amino acids. I would always underline things in exams. I think that's a good idea. Name the covalent bond between two adjacent amino acids in a chain of amino acids. What do you guys think? Let's have a look. Yeah, people do seem to hate chemistry and biology, but it's not too bad. I want to see if lots of you are going to say the same thing. Tamana, you did not sign up for chemistry. Fortunately, this is biology. Yeah, guys, well done. You're absolutely smashing that. So this is indeed a peptide bond. Okay, I would make sure that every single one of you could draw that as well. So just in case you have in your exam a question where you're expected to know what a peptide bond is, as a teacher, I would expect every single one of you to be able to draw an amino acid and to be able to draw the peptide bond that you form, right? So if I very quickly do that, and I've just randomed up where the R group is, just because it doesn't really make too much difference. You guys are expected to know that you have H2O there, so water, hence condensation reaction. You can remove that, get rid of that, and you end up joining your nitrogen and your carbon together, something like that. And that is what your peptide bond looks like. So I would expect every single one of you to know that you've got a C, double bonded to an O, binded to an N, binded to an H, or bound to an H. If you have all that stuff, that is a peptide bond. Okay, if it were hydrolysis, as someone just said, then you would be breaking this bond down. You would add an OH there. That's part of my H2O, and then an H there. There's my water. Anyway, nice and straightforward start. So name a type of reaction involved in breaking this bond and describe what happens in this reaction. So I think the first part's easy. And then the second part, you guys seem to know this already. Let's have a look. So Sadia, hydrolysis, right. First part, let's definitely get that done. So hydrolysis, definitely the case. Let's have a look. Addition of water, yeah, I like that. Removal of water. Ooh, so people are saying different things. So removal or addition. So look at what I just did. So a second ago, hang on, we had that was gone, that was gone, that was gone, that was gone, that was all attached. So to break this bond, I'm not removing any water. I need to add some water. Okay, so I'm going to add some water, or half of it's going to go there, or 2/3 of it, and then the other third's going there. So hydrolysis, using water, or we could say like add in water or something. Okay, that's all you'd ever need to say for that question. So how do you break a peptide bond? You use water, and this is called hydrolysis. Okay, right, another straightforward question. Describe how an enzyme, such as pepsin, breaks down a substrate. Can you guys remember what pepsin does as well, just as on a side note? But if you can, feel free to tell me. If you can tell me how an enzyme will break down a substrate for 5 massive marks, let's give that a go. I'm going to look at my messages that are coming in. So it is in the stomach. Okay, true. It doesn't necessarily have to be. So your small intestines have some pepsin which are released into them, I believe. So induced fit model, lovely. That's really good. Breaks down the proteins. Okay, true. I would try, Mariam, to try not to use the word breakdown. As soon as you get to A-level biology, examiners seem to hate the word breakdown, and it's weird because we all use it all the time and we use it a lot in GCSE, but hydrolyze is much better. Binds to the active site, good. Someone says it's a protease too. Ooh, Tamara, you said enzyme substrate complex, that's lovely. What else can you see? You can't see the full question. That is something I'm not sure if I can do much about right now. Exo or endopeptidase, true. That's if it's breaking down the outside or the inside. Does it break hydrogen bonds? It might break down some hydrogen bonds. It's probably more of the peptide bonds that we're worried about. Blooming neck, guys. You guys there's a crazy amount of you managing to write things in. Right, I'm going to start going through this. So before we say anything about it moving into the active site for the induced fit model, Kiara, you just absolutely smashed it. You got there just before I could say it. So the first thing that we need to say then, here is how's it going to break down a substrate? We need to say the substrate is complementary to the active site. Okay, that is the first thing that you guys would need to say for this question. Okay, so the substrate is complementary to the active site. Sorry, I'm going to try and read some of your comments again because you're getting them in much faster than I can read them. Lovely. Someone has just said something really, really good as well. So someone has mentioned enzyme substrate complexes, which is like one of the key things that you can say in these questions. So I think the first thing we need to say, the substrate is complementary to the active sites. And then let's like logically go through it. So if I've got an enzyme that looks something like that, and a substrate that looks something like that, I think step one is just to say that the active site is complementary. Okay. Step two is we need to talk about what someone mentioned earlier, which is what that enzyme does. So I think, don't know who, I can't, trying to find someone who said it. I think I've got a way back to go. I want to see if anyone else can tell me just from the cuff, like just from now. Can you tell me what's the second like important bit? Tertiary structure of the active site leads to the Caspoli reaction. I do like that. So we could say due to enzymes tertiary structure. I do like that. That is good. Good. Amana, I don't know if that's the perfect way. I don't know if I'm saying your name right, but I like what you're saying. So due to the enzyme's tertiary structure, it is specific. But the important thing we want to say is the induced fit model will occur. So the enzyme will change shape. And we can say, what does the change shape do? What does someone saying it's lowering the activation energy? That is true. If I'm breaking something down, why is that the case? Why does this enzyme change and sort of starting to crush? Oh, sorry, I said it there. Why does it start to crush the substrate? Why is that important? It makes it tighter. It puts pressure on the bonds. Saba, that is absolutely perfect. So we can say that strain is put on the peptide and hydrogen bonds, lowering activation energy. Lovely. What else do we need to say? We can say this is the induced fit model. Someone just mentioned, why is this not the lock and key? Basically, the lock and key model is sort of the old-fashioned way of looking at it, that my substrate fits perfectly in. It's usually not the case. It's normally the case that the enzyme has to very slightly change. But anyway, what else could we say? What do we form? So it's all changed shape. It's all come together. What do we need to say? What Darren said. Oh, I think I just answered that. So yes, good. So Sadia, I like what you're saying. So we want to say that after they've come together, after there is a strain, we want to say that an enzyme substrate complex comes or is produced. Enzyme substrate complex produced. Right, in biology, if you ever see the word complex, it just means two things stuck together. It doesn't really mean anything more than that. What else could we say? In fact, I think looking at my mark scheme I've got in front of me, that is basically everything you could say. So in fact, I like what Sarah just said. So we could say forming products. I like that as an endpoint. I will highlight the key words that got the marks. So if you said complementary, let's change up the color. You guys have no idea how fancy this tech gets that I can make my little thing go blue. So substrate is complementary. That will be 1 mark if you can say that. Right, that will always be a mark to say that something is complementary. Tertiary structure, that will be a mark as well, right? If you ever get a question about an enzyme or any protein, pretty much, be it like an antibody or hemoglobin, if you mention tertiary or quaternary structure, you'll probably get a mark. If we say that there is a strain put on the peptide bond, that'll get you a mark. If you said lowering activation energy, that'll get you a mark. So using just that keyword. The induced fit model, that'll get you a mark. Enzyme substrate complex, that'll get you a mark. That word, if you ever want to you know that thing with biology where you're in an exam and you're like, oh, I really need to think of a word, and I don't know what the word is, but there's got to be a word out there which just perfectly fits. It's probably enzyme substrate complex, right? It comes up so often. But anyway, those are the marks we get. So 1, 2, 3, 4, 5, 6, 7. So there's a potential 7 out of not 6, 5. Right? They're all the things that you would possibly ever need to say. Catabolic, it wasn't a mark for this, Yusuf, but you are right that if you're breaking something, that is an example of a catabolic reaction. Why do enzymes change shape? They sort of just do. For most enzymes to work, they have to change shape. So like with a protein transport molecule as well. They change shape if the pH or temperature is changed. Correct, yeah. With this question, it's only asking you how an enzyme breaks down a substrate. So if it started talking about how the rate was affected, then you could talk about temperature, pH, and stuff like that. But this question is a really straightforward one. Just describe, so tell me how an enzyme basically does its thing. Denature, yeah, we don't need to talk about that at all. Do you not have to mention enzyme product complex? Kiara, yeah, if you wanted to talk about that, you could talk about that as well. It wasn't a mark for this. Okay, cool. I think you guys are fairly happy with that. I'm gonna press on. So this is a question that I've seen people really struggle with before. So I'm intrigued how you YouTube people get on with this. Also, kudos on 326 of you being here right now on a Sunday evening before you start your week. Like, I genuinely was slightly concerned there'd be like 4 of you or something, but 328. Oh, love it. Anyway, so lipids are a group of fatty, waxy compounds. Fatty or waxy compounds. Didn't read it. Triglycerides, that's one type. Phospholipids and cholesterol are examples of lipid compounds which are involved in living organism. So table 7.1 lists the number of statements that could apply to these compounds. Complete the table indicating with a tick. Let's actually do the thing we're told to do. Which of the compounds applies to each statement? You may use more than one tick in a row. So starting with this first one, contains only the elements carbon, hydrogen, and oxygen. Okay, so contains carbon, hydrogen, and oxygen. What ones do we think? So this applies to all live. So triglyceride, yeah, we should know that a triglyceride looks something like this. It's got some carbons, it's got some OHs in it, so it's an alcohol, and it's got a whole load of hydrogens for every little line that I've drawn, which I can't bother to do. So triglyceride, definitely. Someone said all 3. Oh wait, not phospholipids. Cholesterol. Oh my god, the question was in my last test. Good, you might be working out where I'm getting some of my questions from. Right, so phospholipid, the clue is in the name here, right? If it's a phospholipid, it's got phosphorus in it, so it's not that one. I would put a cross in it because some people like when I do that, but I just can't be bothered to. Cholesterol, some people seem to not know very much about cholesterol. So cholesterol is actually one of these, right? In terms of what cholesterol is, basically it's like a weird little precursor molecule which is used to make steroids, so like testosterone and estrogen. I think it's to do with vitamin B as well. But I looked this up earlier because I never knew this, despite having got a degree in this and studied it for a really long time. This is the chemical, like molecular formula for cholesterol, right? I think with this question, because the books I found with the books when I used to revise this, when I used to teach this, they were really vague about cholesterol, and I think people sort of assume a lot about it. But we'll carry on talking about that in a second. So what do you think of this next one? So insoluble in water. Are triglycerides insoluble in water? What do you think? Would you get a mark even if you didn't tick both of them? No. So the way these questions tend to work is it'll be like 1, 2, 3, 4, 5, 6. You get 1 mark per row. Okay, all of them. So insoluble in water, it actually is all of them. So a triglyceride, it won't dissolve in water. Otherwise, it would be useless, right? If that's what your membrane is, it'd be useless if it just dissolved. Phospholipids, I say triglycerides are a storage molecule. Again, not great if they just dissolve. Phospholipids, no, otherwise membranes wouldn't work. Cholesterol, equally no, otherwise membranes probably wouldn't work. Okay, next one. Contains glycerol. So glycerol being this molecule here, right? That's glycerol. A triglyceride, sorry, I think I might have lied to you earlier. That was when it had this long tail thing coming out at the end of it. Okay, so it contains glycerol. Definitely triglyceride. Yeah, well done, guys. Triglycerides, no water, triglycerides, phospholipids, yeah, definitely. So you guys should hopefully know that apart from this weird little, but in fact, what am I on about? I'm just lying to you, apparently. The weird little tail thing is this side, isn't it? I think someone possibly pointed that out as well. If it's a phospholipid, then instead of that, I've got this sort of weird phosphate group, which looks something like that, and it's got some charges in it. So phospholipids also contain glycerol. Cholesterol absolutely doesn't, right? This is one of those things where you never get told very much about it, and people just assume it does. Cholesterol has these weird 4 little rings, and then it's got a little carbony tail. So cholesterol does not have it. Ester bonds. Okay, which ones have ester bonds? I want to see who can tell me the correct answer. Ester bond is the one which I've sort of just shown you. So an ester bond, if I've got a fatty acids always have this structure. So double bond O, OH, so hydroxyl, and then whatever this tail is. This guy would have been a hydrogen. So an ester bond is where you knock off one of them, and you end up getting rid of that, and something like that. So I would always think about an ester bond as being COC or like a cock bond or something. That seems like an easy way to remember it. So it's got COC in it, as someone just pointed out. So are ester and phosphodiester the same thing? Marvel, phosphodiester is what you get in DNA. It's where you have 2 ester bonds and one bond to a phosphate group, hence phosphodiester. So Karima, I like what you've just said. You said that a triglyceride does, agreed, and a phospholipid does, agreed. Cholesterol, you never get too much about it, so don't assume that it does, because it doesn't. Well done. Important in membrane structures. So which ones of these are important in membrane structures? Cholesterol is important, yes, lovely. One of the few things you get taught is that cholesterol has this role in like stabilizing the membrane, making it less fluid, so that definitely does. Phospholipids, also definitely, yes. Triglycerides, cholesterol, as someone just said. Triglycerides are used as like an energy store. That's pretty much it. Final one then, contains fatty acids. The best type of acid in my mind, maybe. What one contains fatty acids? Why? Don't know, it's just a funny name, isn't it? Fatty acids. Right, so triglycerides. Triglyceride is this molecule here, right? So I've got my I've got some double bond O, some double bond O there. That one definitely contains a fatty acid because there's 3 of them, right? My phospholipid also does, because that was just a phosphate group attached to it. Cholesterol. Have you been taught that cholesterol does, or are we assuming that it does? What are we sort of going for here? Assumption or definitely? Marvel James hasn't. Ahmed says controls fluidity. There's lots of no's. Marvel James, your teacher is just annoying. Fair. Assuming. Right. So stop assuming stuff, guys. If you haven't specifically been taught it, just don't assume that that's the case, right? So this one is a big fat 0, right? You definitely cholesterol doesn't have fatty acids. A similar thing, which I've noticed, which I've done in another webinar, is someone told me that viruses have cytoplasm, and nothing in any of the textbooks I've ever looked at says that. It's just, you sort of just assume it does, but it doesn't. So be careful of that. But anyway, they are the correct answers. Don't phospholipids have oxygen, carbon, and hydrogen? Phospholipids, no, they've got phosphate as well. So it says contain only. So be careful there. Describe how the emulsion test for lipids. Describe how to do it and describe what a positive result would look like. So how do you do the emulsion test for lipids? Who can tell me that? Mix with ethanol. Mostly, that's right. Good. And then you shake. Lovely. And then you add water. And if it's positive, you will get a milky, cloudy color. Katie, that's lovely. So to do this test, you add ethanol or alcohol. I think you'd probably get away with saying alcohol, but I would stick with ethanol because it's right. Essentially, ethanol will dissolve some of the lipids. You add water and shake. Essentially, that will knock out any of the fat that you dissolved. It will knock it out of solution, so you'll be able to see it as like not a precipitation, but as an emulsion. And then the positive result for that, as someone said, you'll get a milky or a white or a cloudy or something along those lines emulsion. Okay, so that is exactly what I'm looking for. That will get you those 2 marks. How long is this session going to be? Khadija, it will be an hour, but it's about half an hour from now. To do a test for lipids, translucent, yeah, true. Emulsion, emulation. What about test for protein in milk? If you were testing for protein, you use bioreactors. Anyway, moving on swiftly. I think this could be my last question about molecules. I think it is. But this one's a hard one. So proteins are important biological molecules. Protein structure can be represented at 4 levels, so primary, secondary, tertiary, and quaternary. Below is a set of features that may be used when describing the structure of proteins, such as hemoglobin. So hydrogen bonds, peptide bonds, alpha and beta subunits, the sequence of amino acids, the initial fold-in, the overall 3D shape, and ionic bonds with a weird little mark where I clearly screenshotted it. So select the letters of the features that describe the primary level of protein structure. Cool. I didn't even finish reading that. I like that you're all saying different things. That definitely is quite confusing. So this first question, what's the answer to this first question? So lots of you are saying B, peptide bonds, definitely. So you've got all your amino acids, they're all going to bind together, right? And it's a peptide bond that joins them. The rest of you are saying D, lots of D's and B's. Good. So B and D, D being the sequence of amino acids. Certainly. Well done for that. Select the letter or letters of the features found in the secondary level. What do we think for the secondary level? So be careful of this. So it says found in the secondary level of the protein structure and not in the primary structure. So don't be telling me B and D as well. Read the question. This is crazy. I'm literally just, look, if I show you what my phone's doing, look at that, it's going mad. It's actually not possible to read. So lots of you are saying E, lots of you are saying A. Let's have a look. So in terms of the secondary level, there are definitely hydrogen bonds involved, because that's why I get my beta pleated sheets and my alpha helices. So definitely that. Peptide bonds, done that. Seems to be amino acids. Anything else? Lots of you are saying E, that is also correct. So A and E. So the initial fold-in is going to happen at the sort of fairly early stage. I feel like people are just spamming me now. This is crazy. Select the letter or letters of the features that are found in the tertiary level of a protein that are not in the primary and secondary. Right, go on. Let's have a go. Why not C? Because you're thinking that subunits is different to alpha and beta pleated sheets and alpha helices. G and F, I'm seeing. G and F. Poppy, James, I'll get to that in a second. I promise. Right, so peptide bonds, we've done that, so we can't talk about that again. That one we haven't talked about. That one we have. Initial folding we have. Let's have a look. So C, F, and G. It's not C. So unlucky if you said C. It is F and G. So the overall 3D shape is normally defined as the tertiary structure. So F would definitely be it. And we also get ionic bonds, so we get G. So in my tertiary structure, I've got my ionic bonds, my disulfide bridges, my, what else are there? Covalent bonds, hydrophobic, hydrophilic interactions, something else, hydrogen bonds as well, I think. Anyway, select the letter or letters of the features that are found in a quaternary level. Before any of you get there, I'm going to say that this one is C. So the reason that C is this last one, when I talk about alpha and beta subunits, this question was specifically talking about hemoglobin, or it said such as hemoglobin. So a quaternary structure is where you have more than one polypeptide chain. So you've got like one there, one there, one there, and one there. And you also have non-protein structures, so things that are sometimes called prosthetic groups, which is normally, in the case of hemoglobin, iron, right? So you have a weird structure where it looks something like this. And my alpha and beta subunits are basically these different chains here, right? So some of them are alpha and some of them are beta. So in terms of alpha and beta subunits, it is not talking about alpha helices and beta pleated sheets. If it was, it would say so, but it says alpha and beta subunits. So be really, really careful there. Are disulfide bridges tertiary? Yes. Cool. HA, it's nice to see that makes sense. I'm pleased. Back to red again. So hydrogen bonds also form between water molecules. So describe the formation of a hydrogen bond between two molecules of water and explain why water can form these bonds. So if you had a question like this, what would you guys actually do? So Tomo has gone straight in there by saying that there is a negatively charged oxygen and a positively charged hydrogen, and the angle between them is 100.8 degrees. Nice, I like that. Hydrogen bonds form, yeah, lovely. Water is a dipole molecule, yes, with partial charges on hydrogen and oxygen. Very nice, I like that. Polar molecule, Jai is always saying lone pair, which is not wrong, or he or she, sorry, I don't actually know. They're not wrong about. This is chemistry again, yeah, sorry, it is. Delta positive, I think you mean, yeah, you do mean delta. Delta positive and delta negative, lovely. Ariane, if I'm saying your name correctly, I would do exactly what you just said. Hamza, Leah, Poppy, I'd do exactly what you guys said. Look at this massive space, right? You occasionally in biology can get marks for drawing stuff. So as opposed to describing the whole, I don't know, dipole molecule and all that stuff, you can get a mark if you basically draw it. So if I've got my hydrogen, oxygen, hydrogen, and then a hydrogen, oxygen, and a hydrogen, doesn't really matter how you draw it, as long as you have them, so the hydrogen and oxygen are near one another. You are expected to know that oxygen has a negative or a slightly negative charge. It's slightly more electronegative than hydrogen, which has a slightly positive charge, right? That means that that one is slightly positive, that one is slightly negative, that one is slightly positive. And essentially what goes on is this negative oxygen or slightly negative oxygen will essentially attract the hydrogen over. So there's an electrostatic force of attraction between oxygen and hydrogen. Okay, so the first thing I would do here is I would draw this out and then go from there. So you get a mark just for doing that. If you've shown that there is a bond between O and H, you get that. Because I imagine lots of you would forget to say that the bond exists between O and H, but that is exactly where it does go on. So let's talk about what else we can say. So I think lots of you said it. So there is it's a dipole molecule. I like that. It's a good term. We can say there is, what have I said? Electropositivity or electronegativity even. Electronegative oxygen attracts the hydrogen. What else can we say? What kind of bond it is? Do they mention hydrogen bond at any point? Yeah, it does say hydrogen bond in the question, so you won't unfortunately get a mark for saying hydrogen bond. We could say that it is polar. Yep, someone just said that. That's a really good way of describing it. It is polar. I like that as well. Darren, I like that. Uneven distribution of charge. Right? Any of these terms are going to get even marks, right? So the key ones I'd go for, polar, definitely. Definitely you need to have drawn it so you can see the O and the H next to each other. And then essentially anything that describes why these two things attract is fine. Yeah, you get a mark for labeling it as a hydrogen bond. Oh, fair enough. I wouldn't have given a mark for that personally. Yeah, if you mentioned there being a lone pair, you'd have to then Seba talk about how the lone pair is slightly closer to oxygen, which means that it's slightly negative. Yeah, if you said this was a permanent dipole, fine. Okay, cool. Let's look at another question. Oh no, apparently I've got one more on enzymes, I believe. And then the next one is looking at mitosis and maths, which everyone hates. Everyone hates maths, apparently, maybe. So figure 3.2 shows the effect of increase in the concentration of the substrate PABA on the rate of reaction. Okay. So curve A, this one, shows a rate of reaction without the presence of a competitive inhibitor called sulfonamide. Curve B shows the rate of reaction in the presence of a competitive inhibitor, sulfonamide. Okay, so A without, B with. So explain the effect of increasing the concentration of substrate on the rate of reaction. So explain. So just as a really important note, explain means like say why. Right, you're not describing the shape, you're saying why. So say why the effect of increasing the substrate on the rate of reaction is affected by an inhibitor. So we're talking about this guy, sorry, this one here without. So what are we saying? This topic is enzymes. I don't know. Number of collisions increases. Possibly. So as we're increasing the concentration, there are more collisions, therefore we've got a faster rate of reaction. That is actually true, yes. If you increase the conversation, concentration, you have more frequent collisions. Yeah, cool. Maximum enzymes saturated. Nice. We're using words like saturation and Vmax. I like that. That's one spec in particular that uses Vmax. So the active site isn't blocked. Are you covering all topics or just, I'm just doing some AS stuff. Are they directly proportional? At this stage here they are, at this stage here they're not. Excellent. Ellen, you have done something that very few people remember. You need to mention enzyme substrate complexes because that's the kind of thing we always have to say. So to begin this then, without an inhibitor, we need to say that more PABA can enter the active sites. So more PABA can enter the active site, yeah? If nothing is blocking it, there is no inhibitor, then more PABA can enter the active site. We can say, as there are more, that is the worst there I've ever written, so bad that I'm going to write it again. As there are more successful collisions. Lovely. Jenny, you literally took the words out of my mouth. So there are more enzyme substrate complexes being formed. Do not ever be as lazy as I just was. Never write ES complexes. Everyone knows what you're talking about, but you will definitely not get them up for it. So don't be lazy. And then if we're sort of describing this shape, or not describing it, or explaining why it's going on, why is it that at this point here, it suddenly starts to decrease? The rate stops increasing even as opposed to decrease. So we've mentioned all this other stuff. If I come down, what is PABA? I don't actually know. It's just some substrate. Levels out due to the number of active sites being a limiting factor. Darren, you're very, very close. So plateau is a description. It's not telling me why it's happening. Kiara has just said it. Shadman has also said it. Sarah has also said it. Kamal said it as well. So guys, yeah, you are right. So you need to say after a certain point, so it doesn't have any times on there, after a certain point, all active sites, I'm being lazy again, don't do it in an exam, all active sites are filled. It is saturated, or it's saturated. Rates can't increase. Right, if you said something along those lines, or said that the number of enzymes becomes a limiting factor because of this reason, that would be fine. Okay, so it stays constant. HA, ugh, I don't want to fail. Don't worry, you probably won't if you do lots of revision. Okay, so with an inhibitor then, what is going on? So it said it was a competitive inhibitor. Eden, I hope you're not mocking my handwriting. So the inhibitor binds to, you got deleted for that. The inhibitor binds to the active site. This prevents any substrate from being able to bind. Nice. So you have fewer successful enzyme substrate complexes forming, so the rate is slower. Inhibitor blocks the active site, so there is no space for substrate, less PABA can bind. Yeah, lovely. Really, really good, guys. That's a really good answer. So we can say, so I think it's called sulfonamide, wasn't it? So sulfonamide binds to the active sites. I'm going to be lazy again, AS. When that happens, we could say that there will be fewer enzyme substrate Z, really? Fewer enzyme substrate complexes available or produced. We could say that what could we say to describe this? So if the sulfonamide has bound to the active sites, what could we talk about? I want to see competitive does not change shape. Yes, true. I want to see someone say the thing I'm trying to find. British accent makes me sound sarcastic. I have got that quite a lot. Yeah, I don't mean to sound sarcastic. It just comes across as sarcastic. I'm sorry. I don't do biology. Why am I here? Oh, I like that. So Melissa creates a physical barrier. Yeah, that's a really good way of saying it. So I like to talk about this in terms of like probability, right? So if something else is bound, the probability of something that I want to bind to it binding is massively reduced. So we could say the chances of substrate binding is reduced, or probability is reduced. So I don't know, we could say that the rate is much slower. I think the interesting thing with this is the rate is slower, but it does eventually get to the same stage, right? It will ultimately break everything down because these enzymes are, sorry, these inhibitors are reversible, but it's just a bit slower. Okay. Inhibitor is also complementary. Yeah, I think that'd be a good way of describing this, that it's complementary. King's saying it's reversible, again, lovely. I would say that too. Is it competitive or non-competitive? It was competitive. Bam. Cool. Personally, will say I'm British. I'm surprised someone who isn't British is actually watching this as well. Apart from if you're an international school doing A levels, what is an inhibitor? Something that binds to something, an enzyme, and slows it down. What else are we saying? Increase substrate concentration to weaken the effect. This detail for 2 marks. So no, for 2 marks, you would want to say you're from Wakanda. Nice. You'd want to say that it binds to the active site, definitely. You'd want to say that the chances of the substrate binding is reduced, right? All this other stuff is good, but it's these 2 statements there that will get you the mark. Okay, let's do some maths. I want to see how good you are at maths. So what would happen if it's a non-competitive inhibitor? Essentially, it would bind to the allosteric site, causing the active site to change shape, causing the rate of reaction to just drop off. I'm glad that we're all British here. Tomo, weird question. Anyway, so in onion cells, interphase, which you guys should hopefully know is the bit which precedes mitosis, lasts for an average of 18 hours. Using the information in the diagram below, calculate how long mitosis takes. The figures in brackets show the number of degrees for each sector of the circle. Show your working. Right, guys, I want to see some people. You don't save a video, it'll be on YouTube forever, don't worry. I want to see some people putting in some equations to work this out. How are we going to do this? Turkish language homework, that sounds fun. So 75 over 360 times 18. So 75 over 360 as a percentage times by 18. Lots of you are doing what I did first time when I looked at this question. So 75 over 360 times 18 is incorrect. Read the question, see if you can work out why it's incorrect. So 75 over 360, all of you saying the same thing. So 270 equals 18 hours. Oh, nice, yeah, nice idea. So let's turn 18 hours into minutes first, maybe, right? So 18 hours is 1,080 minutes. Don't need to know that, but it might help. Right, guys, I'm going to give something away. Look, the question says, in onion cells, interphase lasts 18 hours. So this bit here is 18 hours, right? Not the whole thing. You need to work out what the whole thing is. So that is a mistake that loads of people made with this question when I have used this in the past. So interphase is 18 hours. So, oh, that's clever maths. So someone knows that because this is 270, right, they know that that is 3/4. So someone has divided this by 3 to work out how we're going to do this. So they've done 18 over 3, which I think actually no gives you the wrong answer. Damn, I was hoping that would work in my head. Apparently my maths isn't good enough there. Right, the way I would do this, the way I'd come across this is if I know that 270 degrees equals 18 hours, then I want to work out what 75 degrees is, right? So to do this question, I would work out what I need to divide 270 by to turn it into 75. So 270 divided by 75 equals 3.6. Is that right? So that is 3.6. And then 18 divided by 3.6, that is right, equals 5. So with maths, whatever you do to one side, you have to do to the other. So to turn 75 into 270, I have to multiply it by 3.6. So to turn 18 into whatever this value is, like x or whatever, I need to divide it also by 3.6. You could find 1 degree, yeah. So you could do that. That'd be another way of doing it. With maths, this works, doesn't it? So I could divide 18 hours by 270 and then times that by 75. It would get you to the same answer. Guys, you don't need to save this video or anything. It'll be on YouTube. I can guarantee that because I know some of my friends will eventually watch this and laugh at me because I'm talking to people on YouTube. But yes. Can you do 270 divided by 18 multiplied by 75? 217 divided by 18 times by 75. Possibly. If that works on your calculator, then yes. Christine Smith, your teacher probably is a genius. Whole thing is 24 hours. Yeah, I guess. Well, not necessarily. The cell cycle doesn't have to be 24 hours. Guys, so to do this, turn 217 to 75, so 270 over 75, and then do the same to your 18 hours. Let's look at this next question. So the image below shows one cell that the student saw in the onion tissue. So there is a cell in all its glory. So I imagine most of you have done that experiment where you get some roots, you cut off the end, you sort of smush it a little bit, you pour some acid on it, you put it onto a slide, you put, I think it's toluidine blue from my memory, on it, and then you look under a microscope and you can't see anything. It never works. I've never met anyone who's managed to make this work. But this is supposedly that experiment, okay? The student concluded that the cell in the image above was in the anaphase stage of mitosis. Was she correct? Give 2 reasons for your answer. Right, let's look. Arian, you are very close in what you just said. It kind of worked for someone. Liv, I'm amazed. I've literally never heard that ever. Right, so be very, very careful. You are right, Arian. Be very careful with how we describe these things, right? So in anaphase, for whatever reason, we no longer refer to them as chromosomes. So these guys here, these are chromatids, right? When you pull them apart, they are chromatids. So one way that we know that this is an anaphase is because the chromatids, as opposed to the chromosomes, the chromatids are V-shaped, right? That implies that they started off as little X's, which we know, and then the spindle has pulled them at the centromere to either side, which makes them turn into little V's. So the centromere has split. We have made some V-shaped chromatids. So chromatids are V-shaped where they split at the centromere. Okay, that is 1 mark. Okay, muy bien. Second reason, can anyone tell me? Lovely, Yusuf, you've just said the right thing. Who else saying the right thing? Farzi, yes, you're saying the right kind of thing. Vincent, yes, lovely. HA, yes, 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 yes. Guys, you've smashed that. So the other way that I know that this is anaphase is because in anaphase, my chromatids, not chromosomes, get pulled to the 2 opposite poles. So I can say the chromatids are at the 2 poles. Okay, that's lovely. And then I reckon I'm going to finish off on this question and then I'll tell you all the discount codes and stuff like that. So the student counted the number of cells that she observed in each stage of mitosis, which I'm sure you would have been told to do. Of the 200 cells she counted, 6 were in anaphase. 1 cell of the onion root tissue cycle takes 16 hours. Calculate how many minutes, so be careful, these cells spend in anaphase. Show your workings. How would we start this? Someone has smashed this very, very quickly. Someone has not smashed this also very, very quickly. So I think the first thing that I would recommend doing is work out how many minutes we've got in total. So 16 times 60 is going to be 960. If you're wondering what I'm doing, I do actually have my calculator here. I'm just working out as I go. So 960 minutes. In terms of working out then how many are in mitosis, I think you guys know this. I think you're sort of showing me that you got this. So I need to work out roughly what percentage are there. So 6 out of 200 with quick maths we can work out is 3%, isn't it? Because 3 out of 100 is 3%. So 6 out of 200 is 3%. I'm going to just check that because my brain has a habit of being stupid at this time. 0.03, yeah, lovely. So if I find out 3% of 960, so times that by 96, you end up getting, what have I done wrong there? You end up getting 28.8, but my brain has just done something stupid, I believe. 28.8, let's do that again. So 3%, 0.03 times by 960. Yeah, I just didn't put a 0 on. Cool. So I end up getting 28.8, right? I would probably not be confident to write that as an answer. Okay, so I probably wouldn't be confident to write that as an answer. So something with biology that no teachers ever seem to say, and I've never understood this, and it's like one of the first things that I've tried to say, is when you are rounding a question, you always want to try and stick to what they've given you. So if they've given me no decimal places there, no decimal places there, chances are the answer wants you to say it to no decimal places. So the answer to this, I would write as being 29 minutes. Okay, so I would just copy what they've done before you, right? When you start putting like 10 decimal places, you tend to lose marks. So I think with biology, the idea is that you're sort of going for a useful amount. And if in the question they've done 0, then I reckon you should do 0. If they've done 1, you should do 1. If they've done 2, do 2. I'm glad your teachers have said that. When I spoke to people in the past, they're like, oh, I never really thought of doing that. If you put 28.8, would it still be fine? For this question, yeah, 28.8 was fine. But I would just try and get in the habit of rounding it to whatever they've given you. Difference between sister chromatids and non-sister chromatids. When you have a chromosome divide in the replication stage or synthesis stage of mitosis, it goes from being one chromosome, or technically this is called one chromosome at that stage, but it turns into 2 sister chromatids. You don't ever get a single chromatid. Miss Bio usually says, look at the question. Did we do semi-conservative replication? I haven't here, no. Right, guys, what I'm going to do, because I did actually plan, that you'll see how many questions I planned. Bam, look at that. I was going to do loads, but I'm probably not going to. So you might be able to pause that and have a look at them at some point. And then if you sign up to SnapRevise, I'll answer any questions. But I will show you the stuff that we have got on offer. So for those of you that want to see what we kind of do, I'll quickly show you that now. So if I keep this, just so I don't lose everything. And then this is going to go weird for a second. I'm pretty sure I've got you on a second. Do I? No. Don't. Right, let's just load up my SnapRevise. So hopefully you guys can still see this. And you probably see this as a weird little thing. If I drag this down, bam. So if I show you what our website looks like. So essentially what will happen if you guys were to sign up, which you would all be very sensible to do, you'll end up with something that looks a little bit like this. Essentially, we have got this system whereby if you were doing, say, biology, right, you go on to your A-level biology, and essentially what you've got when you get here is you've got all of the course. So we've separated everything into all the useful little chunk bits. So let's further to the top. Essentially, the way it works is you click on whatever it is, so monomers and polymers, and my internet is being slow. And then you'll essentially have some video. In fact, no, before you do that, you'll have some little quiz, which is introducing you. So I think because I've done it before, it's not coming up. So I'll go back. If we go on polysaccharides, let's do that. Let's see if it pops up. There it is. So it will come up with a diagnostic test for you, first of all, right? If I show you what this looks like, essentially, you'll be given a whole load of questions, and this is random. I'm not getting these wrong on purpose. I'm just going to click A for everyone, see if that works. You'll get a load of questions, and essentially, it will tell you what is wrong, what is right, and then it will give you a whole load of videos at the end to tell you what you did and didn't know. Oh, how many questions have I got? 4 more. Let's keep going. Come on, get through this, get through this, get through this, get through this, get through this. I like the loads you haven't logged off. I was hoping like, well, I was worried some of you might. But yeah, here you go. So I got 20% or 2% done. Sorry, 2 right, 20% right. This is what will come up on your screen. And then when you click on get started, look, it puts all the things that I clearly don't know anything about in orange, which is everything, because I don't know anything apparently. And then you'll have a nice little video of some guy telling you some stuff about this, right? So here is some nice little stuff telling you some stuff. What you can do is you can write a comment here. So if I were to write something in now, a question will come to me and I will answer it for you. You'll then get a quiz. Here's a quiz. I'm not going to do that again. Hopefully you've learned something from it. And then you'll get a exam question video, which you can then watch to see like an ideal answer. Okay, so they are our videos which cover the entire course. We also have exam packs. So we have easy, medium, and hard ones. So essentially what you can do when you've started revising this is you can say, I want to do all the hard questions because I know this stuff really well. So compare how the structure of starch and glycogen are related. You'd write your answer down somewhere on a bit of paper, and then to see if it works, you hit find the solution, and there is my solution. Okay, you can do that for all of these questions. And I can tell you, because I've been doing this recently, we honestly have thousands of questions. So for each topic, there are literally thousands of questions. We have a revision guide as well, which you can have a look at. And for this, it'll basically be like, you know, I don't want to say the company's name, actually, I probably shouldn't advertise them for them, but very, very like used textbooks that lots of people like, which I'm sure lots of you are going to mention now. We basically have made that in a way which is hopefully more accessible, slightly more useful to you, because it's specific for your course. So you can have a look at all the stuff, you can print it off, you can download it, you can do whatever you want. Okay. If you were like into that, then we also have our web classes too. So if you were to click on web classes, you will see all the web classes that I've got coming up in biology. So I do a web class 2 days a week. So Monday and Wednesday, I do a web class on year 12 and year 13 stuff. And I've got all my old ones here so that you could click on this if you wanted to, and you could watch an old video of me talking about something. And here's me talking about the light dependent stage, looking all sweet. I'm not going to play it. In fact, I will play it to prove that it works. Be embarrassing if now didn't work. Come on. Hey, there you go. That's me about 4 months ago. You can watch all these webinars. You can go to the drop-in sessions. So I do like online drop-in sessions where you guys basically can watch, or you can ask me any questions you like and I'll do my best to answer them. And yeah, that is essentially what we are offering you. So you've got the ability to do all of these things. And I think we've got some different, we've got some different plans that you guys might want to be having a look at. So essentially, this is what we're offering. So if you like the kind of videos that I've just done, then you'd want to be looking at the ultimate package. And I know it seems pricey. Right? And the way you've got to think about this, or the way that I'd like you to think about this, is our ultimate package, which includes these drop-in sessions, these web classes, and the chat thing I was mentioning. Essentially, I'm your tutor if you go for this. So as opposed to paying like 50 quid per session, which when I have been a tutor before, I didn't actually rip anyone off that much. I used to charge 40 quid a session. But as opposed to being 50 quid a session, it's 50 quid for the whole month. And you can come to 4 sessions a week. So 4, 8, 12, 16 sessions, and it's only 50 quid. So it's not actually as disgustingly expensive as it first appears. We have a pro section, which has the predicted exam packs, and it's got the clever little adaptive learning video things. And then there's a really basic one, which just has the videos, the exam walkthrough videos and revision guides. So it doesn't have all the questions. But yeah, anyway, that is essentially everything that we are offering you guys. And other than that, I'm going to stop sharing this and make it go fully on my face. In fact, no, I'm not. I need to show you the codes as well, don't I? Yeah, that's essentially what SnapRevise is. So if you guys have any questions for me, feel free to ask them now. And otherwise, where am I? Here we go. I'm not going to talk about that. Anyway, this is essentially the last thing. So if you wanted to sign up, here is a code for, it's £10 off your first month. So not as high as I thought. There is a code for £10 off your first month. And otherwise, guys, if you have any questions, feel free to let me know and I'll have a go at answering them. So let's go back a bit. Where in England am I from? I'm Elsa Bolton. I assume you're from Bolton. I am from Essex, which I'm a little embarrassed to say. Why don't we do physics? Physics is starting really soon. So physics doesn't exist just yet, but I think the guy who's doing it possibly started last week. So there is definitely physics from now on. Are we going to do another biology web class? I think I'm going to do a few free YouTube ones, but I don't know when they are just yet. Chemistry we do as well. How do I get this for free? Because I'm broke. Unfortunately, you can't really get it for free. Your special teacher, I hope you were my teacher. Oh, I was a teacher last year, and then I decided I wanted to do something different. So you could have had me if you were around Essex. Do I genuinely think it's worth the investment? Amy, it depends mostly on how well you're doing in biology, how much you need biology in your life. Like if you, for instance, were struggling a bit and you really wanted to get an A star, then yeah, it's definitely worth the investment. Like if you've ever considered getting a tutor, this is a much cheaper way to get a tutor, essentially. And I don't think there's any like really long contracts or anything, so you don't have to like, you can sign up and then if you hate it, you can just get rid of it. But yeah, essentially we're trying to replace tutors. We thought that it wasn't fair that rich kids can get tutors who can pay, and you can pay them 50 quid like per session, and those guys will get A stars, and that's just unfair in our mind. So our attitude kind of is that if we can make it accessible for everyone and also earn enough money to be able to put a roof over our heads, then that would be ideal. Do you get a month free of that code? You get £10 off your first month. I'm pretty sure you could just sack it off after a month if you wanted to. Thank you guys for telling me I'm a good teacher. I really do appreciate that. Blushing a little bit. You're from Bradford, Elsa Bolton. You're not even from Bolton. No, Essex is great. It's so sad we have to be ashamed about where we live. You say that, but I went out where I live the other day and there were police people around, and basically this guy walked up to a police officer and said, "Oh, you're right, mate. Are you looking for me?" And I was like, "Oh, Essex. That's so Essex." Where else are we looking at? Let's have a look. Right, guys, I'll try and answer your questions. Do we do GCSE content? If I'm totally honest, I don't think we have started GCSE content just yet, but I think we are going to in the future. Holly, any tips for revision? Yeah, I think I posted something on Instagram the other day. I don't know if any of you watched that. Essentially, you've got to make sure that you are doing, you're assessing yourself. So for revision, it's literally not worth doing unless you are going back and checking stuff. So doing exam questions is really useful. Things called a power hour, that's really useful. Flashcards with the answer on the back, they make you assess yourself. So just any assessment is good. At the next webinar, can we have a 40% discount? I'll see what I can do. I'll pull some strings. Where do you sign up? I assume it's on the website. Is antibiotic resistance on a spec? Megan, it depends what your spec is. Why do non-polar molecules diffuse into cell membrane? Because the membrane is itself non-polar, so they can move through. It's actually mad that I've learned more in 1 hour than in 2 years. No, I'm sure that's not true. I've got some other videos as well. If you look on YouTube, you'll see some other videos I've done. Do SnapRevise do Edexcel, geography, and business? I don't think we do business. We might do geography. Do I play any sports? I used to play rugby. I've started doing salsa dancing recently, which you probably wouldn't expect to look at me. Favorite sport? Don't know. Rugby, probably. Is it £50 per subject? Cool for cats. I'm pretty sure there's like a discount if you sign up for 2. Any other things? How much time would you spend a day revising? Good question. I think when I was doing my A-levels, I probably didn't revise enough. But I think what I've always said to my students is for every hour you have in class, you want to do another hour reviewing it so you know it. So let's say, and I assume you have 4 lessons a week roughly, because that's what I used to teach. I would say for your 4 hours a week, you'd probably want to do 4 hours of revision, which sounds like a lot, but you have so many frees, I would assume that it's all right. Oh, Tomo, I'm glad I've tempted you. You don't have to, but feel free to if you want to. How to get a grade 9 revision? It's like there's no. I think everyone's looking for this like quick fix, aren't they? Where it's like, oh, if I go to this website and type in this, I'll get an A star or a 9. I don't think there's really much to suggest apart from you've got to work really hard. Like you've got to get to the stage where your revision becomes the most important part of your life. And I know that's sad, and I know you're all like 17, 18, and you probably have other things going on like family stuff and boyfriends, girlfriends, all that kind of thing. And I know those things are going to appear more important, but I guess it's getting to the stage where you have a life and you can do revision as well. And you've just got to do exam questions, stuff like that. Yeah, think about doing some flashcards if you get a chance, where you have the question on one side and then a nice, like, concise answer on that side, and just keep going through it and literally have a big old pile, big old wad of them. And every time you know something, just throw it away. You don't need to have it then. What grades did I get at A-level? I got an A in biology, I got an A in history, B in chemistry, and a B in maths. So yeah, those. Anyway, guys, I reckon I'm going to probably call it a day here. So practice questions are so good. Yeah. If you don't sign up for SnapRevise, again, sign up for SnapRevise. It's really, really good. I think I have to say that, but yeah, you should do it anyway. You can have more of these sessions and it'll be lovely. We can have 152 of you all here. If not, if it's too much, which I understand, I'm pretty sure we might be offering something for people who properly can't afford it. I don't know. I don't want to say anything. I would have a go at having a look at websites like S-School and stuff. I think they have exam questions on. Maths and Physics Tutor, I think they have stuff on. I can try my best to try and get the mark schemes to you, but I might struggle because I don't think we have anyone's email addresses or anything, but possibly. Other questions. I'll be a really, no, I can't really do it. If I tell you roughly what the answers are, that might help you to, if I try and get this to load up again. Don't know how to, hang on. If I do this, I can tell you what the answers are and you can come back and have a look at them in your own time. Oh, in fact, if you can see the screen, here are the answers. All the answers I wrote here on the side. So that's the answer to the first one. That's the answer to the second one. You see my notes I made to myself. There's the answer to that one. This number here should be 23.6. It's 7.5 times by 4, so into 60, times by half of that squared. This one, here you go, here are some answers. But I'll leave it there. Okay. I've written where certain things are for Edexcel and OCR and stuff. There's another one. Here's another one. Good luck with Hardy Weinberg and working out what I'm talking about here. And there you go, that's it. There you go. Yeah, Tomo, enjoy the Golden Compass Dark Materials thing. I do actually watch that. Guys, have a really, really nice evening. I'll try and do another YouTube session fairly soon. But otherwise, sign up to SnapRevise and you can come to as many sessions as you want. There is my face looking massive. Have a lovely evening, guys. I'll catch you at some point in the